Okay, day 3 is going to be evaluating limits. So we're going to do limits again, except instead of doing limits looking at graphs, we're going to put them into equations. And it's really, really easy. Limit by substitution is just plugging in the number for x. And they tell you what number to plug in. If you look at the problem, underneath the limit sign, you see right underneath here is this number 1, or this one. X goes to -3. So all I have to do is plug in this for the first one, plug in number 1. And when I do all this work, I get on the top is 12, on the bottom is -3. 12 divided by -3 is -4, so my limit is equal to -4. Okay, for the second problem, I'm going to plug in -3, and I write it all out. Notice I use parentheses when I plug in a number in for x, especially with negatives, because I want to make sure a negative number squared is still positive. If you plug it without in your calculator, you're going to get a negative. And the top becomes 0, and the bottom becomes 5, and 0 over 5. I like 0 over 5. That's just 0. So that results, that limit is equal to 0. Okay, not too bad right now. Okay, let's go to the third one. I'm going to plug in 2. Oh, that's pretty bad. 5 times 2 plus 6 over 2 squared minus 4. Now when I do that, I get 20 divided by 0. And if you go to your calculator and do 20 divided by 0, you're going to get an error, because 20 divided by 0 technically is undefined. But these are limits, and I don't recall ever answering undefined for any of the limits. You do not. Whenever you get something that is undefined, you put down for limits D and E. Does not exist. Okay, you cannot put down undefined for limits. So going back to looking at the 3 problems we've done, 1, 2, and 3, we plug in the numbers for x that they tell us to, and we got the first one was -4, the second one was 0, and the last one was D and E. So what's going on here? Is there a problem with any of these? Yeah. On number 3, I got a number divided by 0, which is undefined, but I cannot do that. But for a limit, you have to put down D and E. Okay? Limits can never be undefined. If you put down undefined for a limit, you will not get it right. You will lose points. If you have something that you cannot do, such as 20 divided by 0, for the limit you have to put down does not exist, D and E. Now we'll do this last problem. And again, it's telling me to plug in -2. So I get -2 squared plus 5 times -2 plus 6 over -2 squared minus 4. When I do this carefully, I get 0 over 0. Okay, well 0 over 0 is a little bit different. Okay, I'm not happy with this. So is there a problem with this? Yes, there's a problem. 0 over 0 is this very special word, indeterminate. If you ever have time, go ahead and ask Siri on your smartphone what 0 divided by 0 is, and see what she says. She's going to make a nice little joke, but you're going to see that she gives this very special word, indeterminate. So why do I put this frowny face? I put this frowny face here because I'm sad. I'm very sad. The reason I'm sad, because right now, indeterminate, 1, It tells you nothing. At least does not exist tells me something. Okay? And 2, I have to do more work. It's the other reason why I'm sad. So if we ever get a 0 over 0, if you ever get 0 over 0, and you got to put a frowny face after it, I will give you a +1 bonus. But only for problems that you get 0 over 0 on a quiz or a test, and you have to put a frowny face after it. And then you got to do more work. You're not done. You got to still solve the problem. So what do I mean by that? So whenever you get 0 over 0, there's something going on in the problem that's probably some things that are going to cancel out. You have matching factors. So that's why you're getting 0 over 0. So again, the first thing you always do is plug in this number. And we did that on the previous page. And we got 0 over 0. And when I see 0 over 0, I put my frowny face. That means I have to do more work, such as factoring. So when I factor this, I get x plus 2, x plus 3. On the bottom, I get x plus 2, x minus 2. When I factor the denominator, I see that things cancel. And after things cancel, I still have this limit in front of it. The limit as x goes to -2. But the only thing left over now is x plus 3 and x minus 2. And now I could plug in my number for x. -2 plus 3, -2 minus 2. I get 1 over -4. Remember, I still have to plug in my number. So this limit, when I'm all done, is equal to -1/4. Okay? It's not 0 over 0. You can't leave it as 0 over 0. You have to do more work. So in summary, when I do substitution, all I have to do is just plug in x equals a. That's all I'm doing. It tells me right here, x goes to a, plug in x equals a. I get choices. I plug it in, I get something like 12 over -3, 5 over 2, a number over a number. I'm good. I'm done. I plug it in, I get 0 over 5, 0 over -8. I'm good. That's just 0. I plug in and I get 20 over 0, -2 over 0. Now, I'm not exactly excited about it because that's undefined, but my limit is d and e. I'm good with that one too. But if I ever get 0 over 0, I gotta tell myself I'm sad. I make a frowny face. You might get that, and then there's more work to do, such as factoring. Because technically, 0 over 0 is a hole in the graph. Okay? Remember, when we talked about holes on the previous day, an open circle does not change a limit. It's just a missing value. Okay, let's try some examples by plugging in the number it tells me to. I plug in -3, I get negative of -3 plus 2, which is just equal to 5. So this limit is equal to 5. The next one, I plug in -3, so I do negative of 2 times -3 over -3 plus 3. I get 6 over 0, which is undefined, but I never put down undefined for limits. That would be d and e. This next one, I'm going to plug in -1. So I get -1 squared minus -1 minus 2. For -1 minus 2, I get 1 plus 1 minus 2, which is 0 over -3. And I'm okay with 0 over -3. I get a result of 0. And this last one, I'm going to plug in 2. 2 squared minus 2 minus 2 over 2 minus 2. I get 0 over 0. Not happy. Frowny face. So now I'm going to factor. And if you ever get 0 over 0, that means you better have a factor in the numerator and denominator that will cancel out. That has to happen. So I know on the bottom I have x minus 2. I bet you on top I'm going to have x minus 2. And then x plus 1. The x minus 2 cancels out. Now I still have this limit in front, so I have the limit as x goes to 2 of x plus 1. And now I can just plug in 2. I get 2 plus 1. And my answer for that is 3. Now we have a page of practice problems, and it's very easy. It says right here, just plug in the number. Don't forget there's a little negative sign. Negative 3 plus 6 square root of. I get a result of negative 3. Plug in negative 3, so I get the square root of negative 3 plus 2 equals square root of 5. Can't simplify that. Square root of 5. This is the square root of that. This next one, got to plug in negative 1. There's no variable to plug in. That's okay. Y equals 5 is just a horizontal line, so everywhere the result is 5. This next one, move it up a little bit, plug in negative 2, negative of negative 2 minus 3 of negative 2 squared plus negative 2 plus 1. 2 minus 3 is negative 1. 4 minus 2 is 2 plus 1 is 3. And get negative 1/3 as its limit. I'm going to plug in 1. I get 1 squared minus 1 over 1 minus 1. I get 0 over 0. Sad. Got to do more work. I better factor. X plus 1. X minus 1 over x minus 1. How nice is it that I get something to cancel? I still have this limit sign in front. But now the only thing left over is x plus 1. I plug in 1 here. I get a result of 2. And this one says plug in 2, so I get 2 cubed minus 2 squared minus 4. 8 minus 4 minus 4. I get 0 as my limit. Okay, it says plug in 1. Don't forget that negative sign. Negative 1 minus 4 over 1 squared. Oh, that's terrible. Minus 6 times 1 plus 8. Well, this is negative 3, so it's negative of negative 3 over 1 minus 6 plus 3 is 3. Negative 3 is 3 over 3, so my result is just 1. I'm going to plug in 1 here. I get, don't forget that negative sign. 1 squared over 2 plus 2 times 1 plus 4. I get negative a half plus 2 plus 4. I get 5.5 as my result. I'm going to plug in negative 2. Negative 2 squared minus 4 over negative 2 plus 2. Don't forget this negative sign up front. I get 0 over 0. So I'm sad. I got to do more work. I'm going to factor it. There's a negative sign up front. X plus 2, x minus 2 over x plus 2. These cancel. I still have this limit up front of x goes to negative 2 of negative parentheses x minus 2. Now I could plug in negative 2. I get negative of negative 2 minus 2, which is equal to negative of negative 4. That result is just 4. I'm going to plug in negative 5. Negative 5 squared plus 3 times negative 5 minus 10. Negative 5 plus 5. I do get 0 over 0. I get a sad face, so when I factor this, well, I know I have x plus 5 on the bottom, and since I get 0 over 0, I better have an x plus 5 on top, and I do because then I get x minus 2 when I factor it. These cancel. I still have this limit as x goes to -5, but the only thing left over is x minus 2. So now when I plug in -5, I get a result of -7. I'm going to plug in -1 plus 5. Over -1 squared plus 2 times -1 plus 1. I get 4 over 1 minus 2 plus 1 is 0. That is undefined, but I never put undefined for limits. I put down D and E. Do not make that mistake. Now I'm going to plug in 2 here. I get 2 squared plus 3 times 2 minus 10 over 2 plus 5. I get 4 plus 6 minus 10. I get 0 over 7. And I'm okay with that. That's just 0. Now these last two are a little bit more difficult. They're a little bit different than the other problems I've done. Well, but except the first thing I always do is plug in the number. I'm going to plug in 0. When I plug in 0, I get -2 squared plus 6 times -2 plus 8 over 0. 4 minus 12 plus 8 is 0 over 0. Again, I'm sad. Except I can't factor right now. The first thing I'm going to do, I'm going to expand it. So hopefully you remember x minus 2 squared is x minus 2 times x minus 2, and you expand it out, you get x squared minus 4x plus 4. Then I'm going to distribute this plus 6x minus 12 plus 8 all over x. I'm going to look at things, and I notice that 4 plus 8 minus 12 cancel out. These x's go together, and I have x squared plus 2x over x. I still have that limit goes to 0. I still have this whole limit goes to 0. So if I plug 0 in now, I still get 0 over 0. So I'm going to factor it. And when I factor it, I factor out an x. And I have x plus 2 left inside the parentheses. I have an x on the bottom. Because I said, anytime you get 0 over 0, you better have the same thing on top and bottom. These cancel out. I still have this limit as x goes to 0, but I don't have a denominator anymore. The only thing I have left over is x plus 2. I could just plug in that 0. 0 plus 2 is equal to 2. So I can get rid of all this. My result is just 2. So this last one is the most difficult one of them all because you have to manipulate a fraction inside of a fraction. So first thing I did was plug in 0, and I showed that earlier when I was off camera, that I get 0 over 0. So I have to do more work. There's no factoring involved right now. So the first thing I have to think about, how can I get rid of this fraction inside of this fraction? So I do a little multiplication trick. So I look at these two denominators, and I do 4. It'd be nice if I wrote it correctly. X minus 4 over 4 x minus 4. So it's going to multiply all this. The key is that this fraction is equal to 1. So I'm taking this original fraction in black, which is the original problem, times this one in blue, which is a fraction equal to 1. And when you multiply by 1, you do not change the value of anything. What I can do is distribute. So this can multiply this fraction on top and this fraction on top, and things will cancel out. The first time the x minus 4 cancel out, I have 4, plus the second time the 4's cancel out, I have x minus 4 over, and I just multiply all this together. I get 4x parentheses x minus 4. I do notice that the 4's cancel, and right now I have x over 4x x minus 4. And technically, I should look at this and remember I still have this limit as x goes to 0. If I plugged in 0, I get 0 over 0, but I see something else cancels out. I see that this x and this x cancel out. It leaves a 1 on top. So right now I have the limit as x goes to 0 of 1 over 4 x minus 4. And when I plug in 0, I get 1 over 4 times negative 4, or I get negative 1 over 16. So this whole limit is equal to negative 1/16. Okay,